Okay, here we go on section 1.2. We're going to start with the study guide and then I'll do a separate video for the practice problems. So there's a couple of vocab words that as you were going through the Apex text, I was really hoping you would take note of. So here's a couple things that I was hoping you wrote down. First of all, the vertical line test is something we saw in Math 1, and it's drawing a line straight up and down through a graph to see if the graph is a function. If it touches once, if the vertical line test intersects the graph at one point, then yes, it's a function. If it touches more than once, 2 or more points, then it's not a function. So the first thing they're asking here is this graph of the ellipse below. They want us to perform the vertical line test on this. So if I go over here and just draw a vertical line anywhere through that graph, I look to count how many times it intersects, and it intersects twice. So that fails the vertical line test. So the graph of the ellipse below does not pass the vertical line test, and therefore it is not a function. This is now a new word we're going to start testing here, this horizontal line test that's drawn across a graph to see if it touches once or touches more than once. So we've got a couple new words here. A one-to-one function has an x value that corresponds to a different y value. So an x value of 1 goes to 2, an x value of 2 goes to 3. They go to different y values every time. A many-to-one function has some x values that correspond to the same y values. So 1 goes to 1, and 2 goes to 1, and 3 goes to 1. That would be a many-to-one function. It means when I draw a horizontal line across a graph, and it touches more than once, it touches twice, that's a many-to-one function. So this ellipse is a many-to-one function. Well, now it's asking you for page 4 here, looking downward, the graph of the function below, does it pass or not pass the horizontal line test this time? So we're going to go look at the graph in just a second here. Let's make the font bigger, kind of tiny. Okay, so on this graph right here, let's do the horizontal line test. Touches once, doesn't matter where I put that horizontal line, it only touches once. So the graph of the function below passes the horizontal line test. So the graph is a one-to-one function. All right, next we're going to talk about a piecewise function. This is something that I barely introduced you to the other day, and so now we're going to go look at two different parts of this graph. There's two pieces of this same function. First of all, there's something happening here while all values of x are less than or equal to 0. So on this part of the graph here on the left, something's happening, a graph of x. Then on all the values that are greater than 0, on this portion of the axis, well, that's all going to be negative x. So do we remember what the graph of x looks like? That's a graph that starts at the origin and just has a slope of 1. But it wants us to be looking at a line that starts at the origin but has a slope of 1, but it wants us to be looking in this direction. So instead of us continuing to count up 1 over 1 in this side, we really want to envision what was happening back here. So we're going to go ahead and just do a couple dots here. So it would be like here and here and here, etc., etc. So this is the line of y equals x. All the way up until 0, it would stop here. Then the other graph is the negative x, and it goes for all the values of x greater than 0. So now we're just going down 1 over 1, down 1 over 1, etc. So we have two pieces of a graph that form this one graph. One is a line going up, positive slope, and one is a line going down, negative slope. I'm going to go over to the shapes and grab a line here. And then put a line here. And there's my graph. So graph this piecewise function below. This is how we did it. All right, now they want us to write a piecewise function here for this next one. So picture this. A marathon runner donates $5,000 to charity if her time is less than or equal to 3 hours. Let's go grab our equation. Let's call the function f of x equals. And then we do a big bracket. And we're going to do 3 separate equations within that big bracket. So the first one is that the marathon runner is going to donate $5,000 if something. The second equation is that she's going to donate $2,000 if something. And the third equation is that she's going to donate $1,000 if something. So then what's this something? It's her domain. She's saying if her time is less than or equal to 3 hours. So if x is less than or equal to 3 hours. So here's where we need to go in and get a little symbol from our insert symbols here, finding the less than or equal. And that goes with the 5,000, so I'm just going to drag it up a little bit more next to the 5,000. All right, for the 2,000, it's if she's in between more than 3 hours but less than or equal to 4 hours. So here I go writing this next one. I'm going to say from 3 hours to 4 hours. So in between 3 and 4 hours for this one. And then finally, the 1,000 is if her time is more than 4 hours. So x value is greater than 4. So here's our piecewise function. 5,000 if less than 3 hours, 2,000 if in between 3 and 4 hours, 1,000 if greater than 4 hours. That's how we write out our 3 pieces. Now we're going to go graph that piecewise function. So I'm going to first say that it's right at 5,000 if it's less than or equal to 3. So I'm going to go grab a line from the shapes. And I'm going to basically say up to 3 hours. And then we want a nice little closed dot including the 3 hours right there. And then the next part is $2,000 from 3 to 4. So I'm going to go grab my shapes again and go from 3 to 4. So for this one, this is going to be an open dot. Kind of hard to see our open dot there. And then this next one's going to be a closed dot. Sort of better open dot, I don't know. Finally, the last equation is 1,000 at values greater than 4 hours. So we're going to do our last line over here. And we're basically going to go to infinity on this graph because it can go to as many hours as possible. And this is going to be an open dot, then an arrow to infinity at the end. And there's our graph. 5,000 if it's 3 hours or less, 2,000 if it's in between 3 and 4 hours, and 1,000 if it's 4 hours or more. Okay, finally, we're doing one last new vocab word here, and this one is called the greatest integer function. So what did we just learn about that in our apex work? It's defined to be the greatest integer less than or equal to x. So what does that mean? If I have this number of 9.3, I want you to picture a number line, and you've got the integer of 9 and the integer of 10, and you've got this number in between of 9.3. Well, the definition of the greatest integer is that it's less than or equal to your number. So 9.3 is here, so my answer would be 9. It's the integer that's directly next to your number on the number line, the nice big whole number, 9. Let's go look at the next one. F of 4.8. Picture that number line. Picture where the 4.8 would be. So we're going to say F of 4.8 equals 4, the integer that's directly to the left of it on the number line. Finally, this one's F of negative 7.5. So picture on a number line, this one gets a little tricky with negatives. What would go exactly to the left of negative 7.5? Negative 8. Circle your answers where appropriate. The function f of x equals absolute value of x is called the absolute value function. Since it passes or does not pass the horizontal line test, we're thinking about this one for a second, and then we'll go look at the graph. So picture this absolute value function. So if I have some values like -2, -1, 0, 1, and 2, and my function is the absolute value of x. What is the absolute value of -2? +2. What's the absolute value of -1? What's the absolute value of 0, 1, and 2? Let's go plot those dots over on the graph. So picture putting the dot at 0, 0. Picture putting a dot at 1, 1 and -1, 1. Picture putting a dot at 2, 2 and -2, 2. Again, that absolute value graph, those two straight lines, those bars that you picture, I imagine them just going like this together to form this V-shaped graph. So I'm going to go put in this line now. And let's do this horizontal line test on this. So doing the horizontal line test through any value there, it does not pass the horizontal line test. It is not a one-to-one function. So what is it called when it touches twice? An absolute value function is a many-to-one function, because when you draw that line across, it touches more than once. And that's the end.